Welcome to Academic Game Tutorials. In today's class we are going to study die casting, which is one of the permanent mold casting processes. We are studying fundamentals of metal casting and metals for casting. We will cover all related topics one by one. Before starting, if you haven't subscribed to this channel yet, just click on subscribe and press the bell icon. Here, we come up with new videos on different subjects to make the academic studies easier for you. So, into the topic. Die casting. Die casting is a permanent mold casting process, in which molten metal is injected into mold cavity under high pressure at about 7 to 350 megapascals. The pressure is maintained during solidification, after which the mold is opened and part is removed. The molds in this casting operation are called dies, hence the name die casting. The use of high pressure to force the metal into die cavity is the most notable feature that distinguishes this process from others in the permanent mold category. Die casting machines are designed to hold and accurately close the two mold halves, and keep them closed while the liquid metal is forced into the cavity. There are two main types of die casting machines, depending on how the molten metal is injected into the cavity: hot chamber and cold chamber. In hot chamber machines, the metal is melted in a container attached to the machine, and a piston is used to inject the liquid metal under high pressure into the die. Production rates up to 500 parts per hour are not uncommon. Hot chamber die casting imposes a special hardship on the injection system because most of it is submerged into the molten metal. Hence, the applications are limited to low melting point metals, zinc, tin, and lead, that do not chemically attack plunger and other mechanical components. The figure 1 shows the first step in hot chamber die casting, where with die closed and plunger withdrawn, molten metal flows into the chamber. The figure 2 shows the second step in hot chamber die casting, where the plunger forces metal in chamber to flow into die, maintaining pressure during cooling and solidification. After solidification, plunger is withdrawn, plunger is opened and solidified part is ejected. On the other hand, in cold chamber die casting machines, the molten metal is poured into an unheated chamber from an external melting container, and a piston is used to inject the metal under high pressure into the die cavity at about 14 to 140 megapascals. Compared to hot chamber machines, cycle rates are not usually as fast because of the need to ladle the liquid metal into the chamber from an external source. Still, it's high production operation. Typical for casting are the aluminium, copper, zinc and magnesium alloys. The figure 1 shows the first step in cold chamber die casting, where with die closed and ram withdrawn, molten metal is poured into the chamber. The figure 2 shows the second step in cold chamber die casting, where the ram forces metal to flow into die, maintaining pressure during cooling and solidification. After solidification, ram is withdrawn, die is opened and part is ejected. The molds for die casting are usually made of tool steel or mold steel. Tungsten and molybdenum with good refractory qualities are also used. Ejector pins are required to remove the part from the die when it opens. Lubricants must be sprayed into the cavity to prevent sticking. Vent holes built into the mold, since no natural porosity. Advantages of die casting include high production rates, economical for large production quantities, close tolerance and good surface finish. Thin sections down to 0.5 mm are possible. Rapid cooling provides small grain size and good strength to the casting. And the limitations include generally limited to metals of lower melting points, and part geometry must allow removal from die cavity. So, we have studied die casting, which is one of the permanent mold casting processes. Thank you.